Yes.
So we will now go through each of the slide again. So just as a review, so last meeting we have discussed how to find the derivatives of given expressions. So we have determined the second derivative of 3x cubed plus 2 over x, and this is our answer. And also we have determined the first derivative of the quantity 3 square root of x minus 5 raised to 8. And that was your answer. You did well on this. And on number 3, this time we determined the derivative of a trigonometric function, the second x squared. And your answer is this. And I think this was the last part of the review. The derivative of the log of x cubed minus 2x to the base 4. Your answer was, of course, the last one. Okay, so that was the review that we did, and we've discussed that when we speak of anti-differentiation, it's just like finding the integral of a given expression. So let's say, for example, in the case of 3x squared, if you're going to integrate this or process this using the power rule, as discussed already, your answer will be x cubed plus c. And we refer to this x cubed plus c as the antiderivative of the given function 3x squared. And with these examples, I've also mentioned that the process of differentiation and integration are actually inverses of each other. So if you want to actually determine your answer in an integral, all you have to do is differentiate and you will go back to the given expression. So the antiderivative of a given function is actually the integral also of that given function. The C, as discussed, is written there because we are dealing with an indefinite integral, an integral that does not have any limits. Okay, a process of finding the antiderivative, or it's actually the integration process. So in speaking of the indefinite integral, this is our integral sign. This is our given function. That's the integrand. This is the variable of integration, which I emphasize should have a variable the same as that of the function that is given in your integrand. And this C is your constant of integration. Now, the symbol of the integral is comparable to the summation symbol of your Greek letter, summation. And dx is an appendage associated with delta x, the first part of your EMA 101 then. Okay, so we just change the delta x to dx. And the integrand should be the same, or should be having the same variable as the appendage or the differential. We call this the differential. Okay, now we started with a very simple power formula. Okay, interrupt me if you cannot follow through. So when we speak of the power formula rather, you will simply be ensuring that the derivative of the base here, which is x, is in here. It's dx. And what you need to do is just add 1 to the exponent of the x, and what is the corresponding, whatever is the corresponding resulting power, that would be used as your denominator. So you will have a rational answer whenever you use a power rule. So it has one exception when n is negative 1. We call this the very basic power formula. Okay? And this one was the correction then. So it's now corrected in here. So when we get the integral of 3x, we set aside the 3 because it's a constant. We use power rule for the x. So this is understood to be x raised to 1. So that would be then x raised to 2 over 2 multiplied to the 3. So it would be 3 halves x squared. Okay. And we have this second example, which has also an error. So you have negative 2t squared. So you set aside the negative 2, apply power rule to the t squared, which will give you a t cubed over 3. Then you have negative 2. So this is your corresponding answer. For number 3, we also discussed that whenever you see something like this, there's a need for you to expand. Okay, you expand, and when you expand, you use expansion here. That would be x to the 4th plus twice of the product of the first and the second. So that would be 6x squared and the square of the last, which is 9. and you use the power rule again. So this will be your corrected answer. So it's now edited. Okay, so please go through this again because I will share this again to you later. I will show this rather to you later after I'm done discussing. Now, when we want the derivative of a variable that is written in the denominator, just write this as if it's not in fraction form. So you convert the exponent to negative and then use power rule again. And this will be your corresponding answer. Now, I think we ended with the use of the trigonometric functions. So I gave you the integration formula for the commonly encountered trigonometric functions and their combination. So we have here in the last two integrands, the combination of secant u tangent u, giving you an answer which is secant u, and the cosecant u cotangent u, giving you an answer which is negative cosecant u. Now, the others were also discussed last meeting. So as for example 1, so this is just but elementary. So you just set or write rather the constants before the integrals. I say integrals because you will evaluate each of the terms here separately. So you will have 3 integral of cosine x dx and you have 2 integral of sine x dx. So if you will have to get the integrals now, then for the first term, you have the sine of x, and for the second term, you have the negative cosine of x, giving you this answer. Okay, I think there was an error in here. So this one should not be written because your 1 over sine x quantity squared is actually cosecant squared x from your trigonometry then. So if you will find the integral of this, it's one of the basic standard formula that the integral of a cosecant squared x is negative cotangent x. Okay? Then of course you have the presence of the c. Then for the tangent, you have to rewrite the tangent in terms of its equivalent identity, which is the secant squared x minus 1. Then you can split or you can evaluate the integral separately for the term secant squared x and 1. If you do that, the integral for the secant squared of x is your tangent x. And the integral of the dx would simply be the dropping of the d. Or that would simply be the variable that appears in your appendage or differential, and that's the x. Okay? Now, we have here, I think this is the part which I haven't discussed. So you have 3 cosecant cube x minus 4 sine squared x over sine squared x cosecant squared x. You need to distribute the secant squared x cosecant squared x separately to the 2 terms that appear in your numerator, resulting to this. So your cosecant squared, not cosecant class, your cosine squared x paired with your sine squared x would be, what is remaining here is cosine and sine. Okay, I will show to you using the whiteboard what is done here so you can follow through. I'll use the whiteboard class for you to be able to understand what is being shown here. Wait, I'll just go back to what is given. Okay, wait lang. So you have, so I can process to you the steps. Okay, now I'll go to my new share, to my whiteboard. Okay, so your given was this. Integral of 3 cosine cube x minus 4 sine cube x over sine squared x cosine squared x dx. Okay, so we have this. So as I have mentioned, you will evaluate separately the integrals for the 2 terms on the numerator. So you have this one. And another one here. Okay, dx. I forgot the dx here. So you have actually distributed the sine squared x, cosine squared x to the two terms in the numerator. I hope I've copied it correctly. Now, in here you could see that you'll be able to get the cosine squared here. What remains here is 1. In the second one, you will be able to get this one. What remains here is 1. So you will have 3 integral of, so you have a cosine of x over sine squared x dx minus 4 integral of sine x over cosecant squared x dx. Okay? Now, what do you think would be the appropriate thing to do in here? So there are actually several ways of doing this. The answer that was given in the slide is one way. This one is, there's also another one. So let's say I'll have a color that is black here for the first way that you will find the integral. Okay? One way is you will have 3 integral of the cosine, and the sine here is actually cotangent x. The remaining 1 over sine is actually cosecant x dx. This is the one that you saw on the slide. I will go back to the slide later. So I will have here for the second term 4. And if I will pair the sine and the cosine, that would be the tangent of x. And the remaining 1 over cosine here will be the secant of x dx. Okay? I will stop sharing here because from here, you will have an outright answer that was shown to you on the PowerPoint. So your answer here actually would be this one, the 3 cosecant x, because this one, the one that I have written in the whiteboard, will have an outright integral of, for this first part, your answer will be negative cosecant x. For the second part, you will have positive secant x. However, since it's negative here, so that would be negative 4 secant x plus c. So this is one way of doing it. Okay, now I'll show you another way of finding the solution to that same integral that I have shown to you. Okay, we are in this part already, right? You can also use the power rule in this case. So I'll go to the next slide. So you will have 3 cosine of x, then I will multiply sine of negative 2x dx. I will explain later. Let me go back to the next before this, sine and cosine squared. So you have sine x times cosine negative 2x dx. Now, what did you do there, miss? Okay, I will explain what was done in here. You see this? This is a power. If you write the sine and the cosine in the numerator, that would be written as negative, and you copy this too. Why did I do that? Because I can use power rule for the sine, the same way for this cosine, because the derivative of this sine is actually cosine. The derivative of this cosine is actually negative sine. So I would like to use this one, the cosine dx is the derivative of sine raised to negative 2x. The negative sine x is that dx is the derivative of cosine negative 2x. So if you use power rule, you will have a different answer here. So in this case, you will have 3. The answer for the sine of negative 2x or sine raised to negative 2x would be, power rule is sine raised to negative 3x over negative 3, power rule. And for this one, I took already the negative together with the sine for the derivative of the entire thing, cosine. So my answer would be plus 4 times. So power rule here would be cosine, I'm sorry, plus. I stand corrected. You are quiet. If you're going to add 1 to negative 2, this would be negative 1. You're quiet. So you add negative 1. So this one, when you add 1 to negative 2, this would be negative 1 over negative 1. Okay, plus C. Now, what is this? Isn't this cosecant? So negative 3 cosecant of x. What is this? Isn't that negative secant x plus C? So our answers are the same. Whether you use power rule or you use the trigonometric formula that was shown to you. So this one uses the trigonometric formula because this one has an outright integral answer, or you can use power rule. This one in here, we use power rule provided that this u, this entire thing is your u, has its derivative cosine of x dx, and this one has its derivative negative sine x dx. Okay, that's in the case of that particular example, which you can solve using two different ways. Okay, I'm going back to my slide. Oh, sorry. Okay, now for number 5, you have here, okay, a new technique to use. So you have here 1 over 1 minus cosine x. Whenever you see a 1, or rather a reciprocal of the difference of a trigonometric function with 1, or the sum of a trigonometric function with 1, then you can multiply that particular trigonometric function set, this one, by its conjugate. What do you mean, miss, with conjugate? When we speak of conjugate, if you have here a plus, you place here a minus. If you have here a minus, you place here a plus. And since we don't want to alter the original given integrand, you have to multiply a corresponding rational expression equal to 1. So the conjugate of 1 minus cosine x is 1 plus cosine x, and you have to replicate that in the numerator so that this whole thing will simply be 1. In that case, you will have now this one. Okay? I think you know your algebra by now fully well. So you have this. The 1 minus cosine squared x is sine squared x. And you have 1 plus cosine x here. So if you again distribute, just like what was done in example 4, the sine squared of x to 1 and cosine, you will have this. And you will have this. You can see that. And this one is cosecant squared dx. Whereas this one, wait, class, this is a cosine of x over sine of x. You may wonder why you have a 1 over sine of x here, because this one is sine squared. So you split the 2 sine of x in here. The purpose is, I think some of you saw the purpose already. You will have a pair of cotangent for the cosine over the sine, and you will have a cosecant for the 1 over sine. Why do you want this? Because this is one of the standard formula provided to you. The answer to that is negative cosecant. So for the cosecant squared of x dx, o may ko lang, deklaso nga x, your answer should be cotangent x if this is negative. Since this is positive, the answer is negative. So negative cotangent x, and this one has an outright answer of negative cosecant x. Now again, the C. Okay? Hopefully you got that one. So this one is supposed to be negative. So since it's positive, your answer should be negative. Okay? So that would be for your trigonometric functions. In here, you saw the different trigonometric identities. Review only. I place it in here for you to review. You review these different trigonometric identities. That way, later on, they can help you in simplifying integrand that contains them. Now, primarily, the purpose was some students find it difficult to process integrals. It's because their background on the equivalent identities of some common trigonometric functions is not even that stable. So please review on this. Anyway, that would be shared to you. And I think it's also present in your notes in Canvas already. Okay, now we go to the last topic, which is substitution. Now, later on, you can have your questions. You can raise your questions if you have any. Now, if u is equal to g of x, we know that when we determine the derivative of u, that would be g prime of x dx. This is how we represent the derivative in your differential calculus. So if your f of u du could be split into two functions f of g of x times g prime of x dx, then you can process the integral of this, the integral of your f of x gx, because its derivative is already provided to you. This one was already shown to you in part when I gave you the power rule, the other way of solving example number 4. So I will explain. I'll go back to that particular part so that this will be made clear to everybody. Okay, it's the same thing as this one. This one, I'll use a different font so you would see. This is your, according to that, this is your f of x, and this is your f prime of x dx. So, this is your f prime of x, and this is your f of x. Your f prime of x with your dx is now coupled with your f of x. So in that sense, you can use power rule. In this case, the same thing. This is your f of x, and this is your f prime of x, and this is the dx in here. F of x with f prime of x dx can lead you to using the power rule, which is actually the method of substitution. The one that was shown to you in the slide, I'll go back to that, is just g of x. Okay? So f of g of x, g prime of x, meaning the derivative of whatever is in here in the function, will lead you to using the power rule. So recognizing the u du and the u raised to n du pattern. So this one, that's the u raised to n du pattern that I have shown to you in the other way of solving example number 4. Then you can also do multiplying and dividing by a constant. That way you will complete, that way you can complete the derivative g prime of x. Now these two you will see in the successive examples that will be shown to you. Okay, wait class, my battery is low, please wait. The battery is not good. Can I use your something glasses case? Yes, for now. I'm gonna use that for my dog's dresser. Wait. Yes, you can do that. Okay. Let me check class. My battery is not. Let me just check. How come my battery is not charging? Excuse class. It's not really charging. Wait class. Oh, I did it. You did it upstairs. Okay. Hopefully my 20 minutes, I think there's something wrong with my cable already. Hopefully my 10 minutes will be enough. So I'll go back to that one. I will just finish this class. Sorry for that. Anyway, which part am I now? Here. So if you have, in this case, 5x cubed plus 1, then you have the 15x squared dx here. If you look very closely to 5x cubed plus 1, if you're going to differentiate it, if you make that as your u, if you're going to differentiate it, that would be 15x squared. And that's the exact thing that you have here. So in that case, you can use power rule to this entire thing, which is understood to be raised to 1. So your answer would be 5x cubed plus 1 quantity squared all over 2. Why? Because this is your f of x and this is your f prime of x. So you use power rule and example number 1. Now in the case of example number 2, this thing in the denominator, which is x squared plus 6x, is under the square root sign. So it's understood to have an exponent of negative 1/2 because it's in your denominator. Now, if you make this as your u, the du of this would be 2x squared plus 6. Now, if you will have to expand what is written in the numerator, that would be 2x. Rather, the derivative of this is 2x plus 6, and this one would be 2x plus 6 as well. So telling you that you can use power rule for x squared plus 6x raised to negative 1/2 and make that x squared plus 6s raised to 1/2 because you're going to add 1 to negative 1/2, making it as 1/2 over 1/2. So this would be over 1/2, and that 1/2 would be 2 times the quantity square root of x squared plus 6x. So this is your answer now. You have u raised to 1/2 over 1/2 plus c. That u is the square root of x squared plus 6x. Now, if you move forward, so let's say we'll try it with the trigonometric function, your sine of 10x dx, your u in this expression, if this is sine u du, your u is 10x. The derivative of that is 10 dx. So it's here, the 10 and the dx. So meaning you can apply the trigonometric formula for the integral of the sine u because the derivative of the u in your sine function is in here. It's 10 dx. So your answer is negative cosine u plus c with the u being equal to 10x. So it's negative cosine of 10x plus c. Okay, we'll move on. In this case, you have a cotangent cube x in the denominator. If written in the numerator, this could be cotangent negative 3x or cotangent of x raised to negative 3. What's the derivative of the entire thing of cotangent x? That's negative cosecant squared x dx. So the derivative of the cotangent function is present here, telling you that it's all right to use power rule for cotangent of x raised to negative 3. So what will happen is this. Your cotangent of x raised to negative 3 plus 1 would be cotangent of x raised to negative 2 over negative 2. So in this case, you have negative 1/2, and this cotangent squared of x in the denominator is now written as tangent squared of x because anyway, the tangent and the cotangent functions are reciprocal of each other. Okay, so you see this? You use power rule for cotangent of x raised to negative 3 because the derivative of the cotangent is negative cosecant squared x dx. So power rule will lead you to cotangent of x raised to negative 2, the one you see here in the denominator, over negative 2. So this is it. Now we just wrote the cotangent squared in the form of its inverse because it's in the denominator. So that would be your tangent squared of x with negative 1/2. So the 15 here is this one. Without the use of substitution class, you will have to expand this. You expand this, and the expansion you will multiply to x squared. But the beauty of this is, if you could see that the derivative of the thing inside the parentheses is found together with it, like in this case, class, the derivative of x cubed minus 1 is 3x squared. It only lacks 3 in here to make it complete. So derivative of your u, which is x cubed minus 1, is 3x squared dx. So you need to assign a 3 here so that you did not change anything. You place a 1/3 outside the integral. Just like it's multiplying the original expression by 3 over 3. So 1/3, and then you have now the complete integrand, which you can use the power rule of. So this one, you just add 1. So this would be 5 over 5. The 5 in here goes with the 3 in here to make it 1 over 15. And your x cubed minus 1 raised to 4 becomes x cubed minus 1 raised to 5. Okay? That's it, using substitution. Here we have the 1 plus x squared raised to 1/3. Your u is 1 plus x squared.